High above our world, far beyond the clouds and the quiet blue sky, lies an invisible fortress made of pure energy. Shaped by Earth's magnetic field, the Van Allen radiation belts form vast, toroidal rings of charged particles. Electrons, ions, and solar wind debris, swirling in an ever-changing electromagnetic trap. To satellites, these belts are dangerous. To astronauts, they are lethal without shielding. To Earth, they are a shield, a guardian against cosmic radiation and solar storms that would strip our atmosphere bare. But in recent years, an unusual question has emerged from the edges of scientific speculation and astrobiological curiosity. Could the Van Allen belts act as a natural net, capturing alien probes that might enter our planet's magnetic sphere? It is a question that mixes physics with imagination, engineering with the unknown. A question that forces us to look at our magnetic environment not just as a shield, but as a possible cosmic trap. To understand whether the Van Allen belts could capture an alien device, we must first understand the force behind them. Earth's magnetic field creates two swirling bands of high-energy particles, an inner belt packed with intense radiation, and an outer belt that shifts and expands with the solar wind. Together, they form a region where charged particles follow spiraling, looping paths, bouncing between the poles like cosmic prisoners. Spacecraft engineers know these regions well. Electronics short-circuit, instruments degrade, and unshielded hardware is slowly eaten away by relentless radiation. Anything entering the belts, whether a satellite, a space rock, or a hypothetical artifact, must contend with these chaotic electromagnetic forces. Charged objects can become locked into stable orbits. Neutral objects may be slowly charged by solar radiation and begin drifting along magnetic field lines. It is not impossible for a device, natural or artificial, to become snared here, held in a magnetic web that circles our planet like a forgotten halo. The notion of alien probes trapped around Earth is not born of science fiction alone. Astrobiologists, SETI researchers, and planetary scientists have long considered the possibility that advanced civilizations might send robotic scouts, silent observers capable of drifting through star systems, gathering data, waiting patiently. These are known as Bracewell probes, theoretical emissaries designed to watch civilizations rise. Other ideas suggest lurkers, devices positioned near planets of interest, hiding in stable orbits or magnetic zones to avoid detection. If such probes existed and entered Earth's magnetic environment, could the Van Allen belts ensnare them? Could they be drawn into predictable paths, held in place by forces stronger than gravity alone? It is a possibility that fascinates researchers, not because we have evidence of such probes, but because the physics does not forbid the concept. If an object were caught in the Van Allen belts, what would we expect to see? It would likely follow one of the same paths as charged particles, drifting, spiraling, or mirroring between magnetic poles. Its orbit would not be smooth. Instead, it would wobble and twist, influenced by geomagnetic storms, solar flares, and the slow breathing of Earth's magnetosphere. Radiation would bombard the object constantly. Unshielded materials would degrade and chip away. Coatings would fade. Electronics would be pushed to the brink. And yet, a sufficiently advanced device, built to withstand radiation or powered by magnetic flux, might endure indefinitely, hidden in a region few satellites dare to linger. It would be a perfect place for something to hide in plain sight, a dangerous zone we rarely examine up close. Have we found anything unusual in the Van Allen belts? The simple answer is no. Nothing that definitively suggests alien technology. What we have found is debris, Old satellites, fragments of rockets, forgotten hardware drifting in strange and sometimes unpredictable orbits. These objects interact with the belts, charging and discharging as they pass through regions of intense radiation. To date, no spacecraft or sensor has detected anything out of place. Nothing that cannot be explained by human activity or natural processes. But the belts are vast, dangerous, and poorly explored. We skim them, sample them, fly through them, but rarely linger. Their radiation makes long-term observation nearly impossible. In that sense, they remain one of the least mapped regions of near-Earth space. Although the Van Allen belts are dramatic, they are not the only places a hypothetical observer might lurk. Scientists have proposed several locations where alien probes, if they existed, would have better vantage points and safer conditions. One option is the Earth-Moon Lagrange points, places where gravity balances to create stable pockets of space. Another is the geosynchronous belt, where satellites hover motionless over Earth's surface. Still another is the Earth-Sun L1 point, where spacecraft like SOHO and Discover keep watch. These regions are stable, predictable, and rich in opportunities for observation. The Van Allen belts, by contrast, are chaotic, a swirling storm rather than a quiet perch. If alien technology sought stealth, longevity, and efficiency, there are calmer places to hide than Earth's radiation belts. Still, the question remains: could the belts reveal signs of artificial activity? Some scientists propose looking not for objects, but for patterns, magnetic disturbances that do not match natural behavior, radiation anomalies that repeat like clockwork, or signals that appear anchored to a stable orbit within the belts. Advanced probes might not reflect light or emit radio waves, but they could alter their environment subtly, creating footprints in the magnetic landscape. But so far, nothing unusual has emerged. The belts hum with natural chaos, their energies shaped by the sun, the earth, and the vast forces between them. If intelligence is there, it leaves no obvious trace. The idea of alien probes in our magnetic field is not about fantasy. It is about perspective. It challenges us to examine every environment, every orbit, every shadow for clues. It forces scientists to consider how an advanced species might observe a world like ours, what physics they would use, what strategies they would deploy, where they would hide if they wished to remain unseen. In asking these questions, we learn more about ourselves. We learn how we might one day explore other star systems, how we would position our own probes, how we might observe emerging civilizations light years away. The exercise sharpens our imagination and our science, whether or not alien probes hide in our radiation belts. The Van Allen belts remind us of something profound. Earth is not unprotected. Our planet generates a magnetic shield that extends tens of thousands of kilometers into space, deflecting deadly radiation, sculpting auroras, and preserving the fragile atmosphere that makes life possible. They are a testament to the interplay of physics, magnetism, and life itself. A reminder that Earth is a living world, wrapped in a cloak of invisible power. And they remind us that any visitor, natural or technological, must pass through this storm to reach us. Could the Van Allen belts trap alien probes? The physics says, possibly, under the right conditions, with the right materials, in the right moment. But the evidence says, not yet. No signals, no artifacts, no metallic ghosts drifting in the magnetic dark. Still, the question invites us to look up, to see our planet not just as a home, but as a fortress, a target, a mystery. It invites us to explore the space around Earth with new curiosity, to map the invisible structures that shield us, and to search not for aliens, but for understanding.